so I can get the knee fixed, to our club meeting. And tonight we have a special guest here, Scott Sanders, who will wow us with his presentation, of course. Scott's a longtime friend. He's a fellow instructor or instructor trainer with IANTD and TDI, both of which we're active and involved with there. He's also our factory or manufacturer's rep for the Subgravity line and for TUSA, right?
That's right.
TUSA and UK, Underwater Kinetics. So several of the lines that we have in our retail store, Scott is also responsible for helping us bring them here and have them. So, without further ado, let me turn you over to Scott and talk about scooting and rebreathing and all the fun stuff.
Sure.
Right.
Awesome. Well, thank you, Dave.
Yes, sir.
I actually met Dave when the shop here ran a trip to Florida Keys Dive Center, probably 15 years ago, maybe. I was just a couple of years out of college and decided I wanted to give up my day job and go get paychecks in paradise. Bought a sailboat, moved down to the Florida Keys in a van and lived out of it. And it was paychecks, but little paychecks. And then groups like you guys would come down, and that really excited me because you could see the community. And so fast forward, I actually moved back to Virginia, finally got out of the Keys trap, and started a dive shop while I was in graduate school. And never really gotten a real job since. So, it's part of that Keys mentality, I guess. And the reason is because, this is a very successful dive shop. I'm sure you guys have been to others that are much smaller and not as organized, and that's the way most dive shops in the world are. You guys are very lucky to have the resource of the community and the facility and just having a business that actually knows how to run like a business. That's what I had, a small thing that wasn't really going to survive, and then one day there was a ad for to be a sales rep. So I applied to that job, and since then I travel up and down the East Coast and visit dive shops from this size all the way down to ones in people's garages, and basically mentor them to be better dive shops and to build communities using you guys as an example a lot of times. So that's a testament to the business here and Dave, but all of you guys as individuals for going on those trips and taking classes and all the 3 E's that keep the dive community together.
That's it. None of it's possible without everyone in this room. And
yep.
So, we're appreciative and grateful for everyone's involvement here at whatever level that is, and however often we see their face in the store. We're happy to have everybody on board.
Perfect. So the reason I'm here is because I'm the sales rep with Subgravity, along with a few other brands, and I'm also a very passionate technical diver. Haven't always done that. I mentioned I lived in the Florida Keys, and you guys have been there probably, or at least seen lots of information about it. You go out to the reefs, they're 100-ish feet deep, or the wrecks are 100 feet deep. You go down, you spend 15 minutes, you come back to the surface, you wait an hour, and you go back for 15 minutes, and you did 30 minutes of diving on the bottom that day. Then you go back and enjoy yourself and go back the next day. And if you go down for a week, that's 30 minutes on the wreck for times 5, so that's like 5 hours of diving that you actually got to touch the shipwreck. When I learned about tech diving, I discovered that you could take one of these units and go down for 5 hours and just stay and do a week's worth of diving in one day. Pretty interesting, right? So tonight I'm going to talk about the benefits of rebreather diving and technical diving in general, how a rebreather works, and I'm happy to do that super high level, or before you guys got here, the first few people are asking some very technical questions. So I encourage you to ask questions as we go along, and this can be an interactive thing, and I can figure out exactly how deep you want to go. There's always a question of what it costs, not just to buy the units, but to dive them each dive and to maintain them each year. These are two very similar looking units, but there's also other types. as well as what training is required to get started, as well as after you take your first class, what other courses can you take as continuing education after you start diving a rebreather. So is that what everybody's happy to hear, or add anything to this list before we get started? And how much time do we have? Until 8, or what do you?
I think you're on to start.
Okay. Until we run out of beer, right? Okay.
The price of helium.
Perfect. So as we go along here, the products I'm going to talk about are these. It's Subgravity distributes this unit called the XCCR. They own the rights and also sell the Defender CCR. And then, as an encore, we can talk about the DPV system that they have. I've got some flyers here. I've got some Subgravity stickers and pins for you guys to take. And this is my contact information. So it's scotts@tusa.com. And then that's my cell phone number if you want to call or text. So, has anybody here ever dove a rebreather? Is anybody certified? 1, all right. 2, has anybody ever been on a boat with a rebreather diver? Okay, so you've seen a few. Has anybody ever dove any other type of decompression diving? So either doubles or side mount? All right, so a few. And then what's keeping everybody from doing that? Anybody have a good reason not to do that? What in your mind is keeping you from going down and diving at 100 feet for 5 hours?
Well, the boat's deep enough to know.
So the boat's not going to be there when you get back. So let's dial that back. Let's say 2 hours, right? Right. So if you're going to go down for 30 minutes and then come up and stay on the surface and then go down for 30 more minutes, the boat's going to be there for 2 hours. Right? So what are some other things in your mind that you've heard about rebreather diving that I can dispel or prove?
How to maintain.
Okay, so the maintenance costs.
Preparation.
Safety.
All right, is it actually safer? All right, the cost of the unit, that's usually a big one. This is more expensive than some of the other stuff out there on the shelves.
Seems complicated to operate.
It does. If you guys were watching those videos beforehand, you got to do a procedure before the dive, and there's a lot of stuff on you. Not just this, but also enough open circuit gas to bail out. So sure, it is perceived more complicated. Well, a lot of those risks and complications are mitigated by more training, right? So you take a training class and you learn how they operate, and then it's simple because it's just like, you don't have to know how to change the oil in your car to be able to drive a car. You don't have to know how to, work on the computer or tune whatever, or you don't even have to know how to change a tire to drive a car, right? You just go and do it. So there's some units that can really be broken down in a very good class to where it's as simple as that. And then if it doesn't work, you know not to drive it that day, right? And you take it to a technician just like you would your reg, right? Your regulators, if they started free flowing, you may, put your thumb in there and stop it. That'll stop the free flowing. You may, adjust the little dial on there. Okay, now it breathes better. But if it just didn't work, you would take that back to the shop and they would work on it. So you don't have to be a technician on the rebreather system to dive the rebreather, right? But there's some benefits that even these concerns typically outweigh when you lay everything on the table. So has anybody ever taken pictures underwater? Right? And what are you taking pictures of? Shipwrecks, right? We were looking at some pictures of the cenotes earlier. What about fish? Right? And so if you're diving and you're blowing out bubbles and you're being super loud and you come in here and you're going to take a picture of this fish, do they always just sit still for you and pose perfectly?
The mantis like it.
Some fish probably do like it. But no, it's going to scare them away, right? If you came in here and just started, walking loudly, everybody in the room is going to look over at you. And that's going to alert them, and their survival instinct says, hey, go hide under this rock. And you're not going to get a very good picture when the fish is hiding under the rock. Whereas on the rebreather, it's just totally silent. I mean, you can't even hear yourself breathe when you're underwater. And you can go and you can take a picture of the fish, and they think that you're one of them. And you get much, much better pictures of fish and of the whole environment. So even if you're taking a picture of the shipwreck, you got all the fish in the background, you got this school of fish that swim through, whereas if you're there just blowing bubbles, it's like you're beating a drum down there, and they're not going to swim through as naturally. So that's a huge advantage. When you go diving, your instructor probably talked to you about getting like dry mouth and it just not being as comfortable after a longer dive, like being an hour in the water. And why is that? Why does your throat feel funny when you're diving?
Right here.
Because the air,
humidity we have in our gas here.
yeah, the air has no moisture, right? If you've ever seen a compressor running, every like 10 minutes or so, it'll make a funny noise, and that's actually blasting off the air or the water that's built up inside the compressor, and then there's literally a jug of water sitting beside of it, and that's all the moisture that's been sucked out of the air that you're going to start breathing. On a rebreather, you've got this loop, right? A mouthpiece that goes in, and you exhale, and it goes around in a circle, and you rebreathe the same air that you just took a breath of. So it's not dry. It's also not cold, right? So even if you're diving, what's the quarry right now? The 70s? At the bottom. So if it's 59 degrees on the bottom, that means your scuba tank is also what temperature? 59 degrees. So that's like sticking your head in the refrigerator or freezer and breathing. You think that's going to make your body cold? Definitely, right? And so there's actually so many nerve endings and so much surface area inside your lungs, and when you take a breath of really cold air, it sucks the heat out of you. Whereas if you're taking a breath of warm air, that's going to heat you up from the inside out. So if you're in 50-degree water, or more realistically, if somebody's comfortable in a wetsuit in like, say, 70-degree water, that's reasonable, right? 70 degrees is not that cold, but it is. It's chilling your body and refrigerating your body, and especially if you're breathing air that's that temperature. On a rebreather, because you're rebreathing that air, and it's actually an exothermic reaction happening in the CO2 absorbent, it's actually heating up that air. So you're breathing warm, moist air that just makes you so much more comfortable and so much healthier compared to open circuit. Right? And then we were talking earlier about the boat leaving after like 3 or 4 hours. So that's a stressful thing, right? That's why everybody has to dive with a computer, so that way you know when to get back to the boat. Well, every single breath that you take on your aluminum 80 during the dive, that's one less breath you have to get back to the boat. So think about cave diving or wreck penetration or any of those other types of dives to where you got one way in and one way out. You can't just go in one direction like a drift dive and then pop up wherever you want. So you have to actually plan your dive according to how many breaths you can take. That's stressful, right? Well, on a rebreather, it's more based on how much CO2 you expire, and then it will absorb, and then how long that reaction can take with a certain amount of chemicals in this scrubber, right? And so typically it's about 1 hour per pound, and this is a 5-pound scrubber. This one holds an 8-pound scrubber, which means the limiting factor is literally what's in here. So you could dive for 8 hours or 5 hours, and it doesn't matter what depth you're at. Right? So you guys remember your open water class? On the surface is 1 atmosphere, 33 feet is 2. So if you can breathe your aluminum 80 down in 1 hour just sitting here in the room, how long would you have at 33 feet?
30 minutes.
Yeah, half of that, 30 minutes. So imagine going down to 100 feet. You have even less time. But what if you wanted to go to 200 feet or 300 feet? One aluminum 80 is not going to last very long at those depths. But on a rebreather, because it's depth independent, you're rebreathing that gas, and the only thing that comes from one of these tanks is just what your body consumes. Just a tiny little bit of oxygen. And it consumes the same amount of oxygen at 33 feet as it does on the surface. Also at 300 feet. So literally the rebreather takes as much oxygen at any of those depths, and you just go do the dive. Now, if you're diving in current or you have a lot of gear and you're, moving yourself, just the same thing as like you walking across the room versus running across the room, your body's going to consume more oxygen when you're running. Right? We all agree to that? Yep.
Is this the same technology the astronauts use?
Basically, if they were walking outside of the space or the shuttle environment, in the extracurricular vehicle.
EVA.
Yeah.
Extravehicular activity.
Yes, EVA. Then yeah, they're effectively doing the same thing because they wouldn't want to waste all that extra gas, right? When you inhale off the scuba tank and it's got 21% oxygen in it, what do you think you're exhaling when you blow out?
16, 17.
Yeah, it depends on how long you hold that breath in, right? But if you just breathe it out really quick, it's probably like 20 or 19. You take almost none of that oxygen out of it. Now, if you hold your breath, like a free diver would for 2 or 3 minutes, there's very little oxygen left in there. But you're not going to do that in a normal scuba diving environment, right? You're going to be breathing normally, so it'll probably be 16 to 18%. That means you're wasting most of it. 80% of it or more, that oxygen is just leaving. So you wouldn't do that in a space environment. You would rebreathe it. So it's similar. I don't actually know. I'm not an astronaut. Just sort of guessing.
In the space shuttle, they're generating their own oxygen. But in submarines, in any emergency system in a submarine, where they lose their ability to make oxygen, they switch right over to the same chemicals and the same systems in a submarine to recycle the air as long as possible.
Oh, for the whole sub.
The whole sub, yep.
Yeah, so that's a couple of the benefits, just to kind of get your attention before we get into
How's
the...
it deal with pressure? Are you going to go into that? I mean, in other words, you go deeper. Don't. With a standard regulator, you're breathing a more dense, pressurized gas. What happens here? Because you're rebreathing.
Sure, that makes sense. Does everybody understand the question, right? So we talked about pressure and volume, right? So the third part of that is density. So the molecules are literally closer together. That's why you're breathing more of them for the same breath in. Well, eventually it becomes harder to breathe because the gas is much denser. Well, conveniently, we also have another problem with depth, and that's narcosis, right? So has anybody ever dove to 100 feet deep before? Right? And what happens to your brain about that depth?
A little fog.
Yeah, it's like you've had too many Yinglings and Coors Lights, right?
Yinglings.
So, some people call that like the martini law, right? So you go deeper and the gases in your brain aren't as normal as they are on the surface, and so we don't exactly understand what's going on there, but the fix is to take out the oxygen and nitrogen and put something else in there, and the most common gas for that is helium. So for me, my personal limits are at 100 feet, I start putting helium in the mix. So I would not do a dive to 130 feet on a rebreather or any other technical dive, or I don't even like to teach, be responsible for students at 130 feet. So the nice thing about helium is it's very, very tiny molecules. And so if you compress a bunch of really tiny molecules, it's almost like normal molecules. And so because as we go deeper and the gas gets denser, we're also mixing helium in there, and that sort of mitigates that. So unless you're just doing some really deep air type rebreather dives, it's not as big of a concern.
Well, I was asking more about your body's getting compressed, so your lungs get compressed. Does this thing put pressure into the system so that your lungs equalize to the exterior pressure?
Yeah, so you're always breathing the ambient pressure at that depth.
Okay.
Yeah.
Remember how we teach about your lung volume, right? And how your lung volume doesn't change, right? We talk about taking a picture at depth, right? Your body doesn't look any different than it does now. So your lung volume's never changing. When you're breathing with a fixed amount of gas, like a standard scuba tank, then you're going to take more of that gas out of the tank, right? The deeper you are, the denser it is, to fill that same volume. The rebreather adjusts that by adjusting the loop volume, which Scott's going to talk about in a minute here. But you always have a lung full of air available for you to fill your lungs.
Okay.
One of the advantages also Scott didn't quite mention, he talked about diving inside of wrecks and diving inside of caves, is the fact that your exhaust bubbles, and many of you have been in wrecks with us, and many of you have not been the first guy in the wreck. And the bubbles that you're exhausting are going up and scrubbing the little rust sickles off of the roof and creating a cloud storm of limited visibility the more people pass through. With a rebreather, you go in and it's as clean coming out as you can. I've dove some caves in Mexico that had very porous ceilings, and our dive in was crystal clear water. We're just doing great, and we turned around to come out and it's like, oh my God, who wrecked the visibility here? It was simply our bubbles on open circuit that just went up, scrubbed the top a little bit, dislodged a few things, and it came down. A few hours, it'll be clear again. But why we needed to come out, we had to deal with that. You wouldn't have that issue with the rebreather and not releasing your bubbles.
Yeah, it's like taking your hand and raking it across the surface of whatever. And in a cave, when it floods, it puts mud everywhere. And so the other aspect of that is, has anybody ever dove in a cave? Like Jenny Springs, right? You look up and, you know, the ceilings are just white. They didn't start off as white. We took our breath in out of our scuba tank and exhaled and now spit 18% oxygen up there, and it oxidized the ceiling where there's never been oxygen for 100,000 or 20,000 years or whatever. So from a cave conservation standpoint, we're actually doing damage and hurting the caves by taking oxygen and putting it inside of the caves, right? It gets even worse in wrecks, right? Because what happens when you exhale like into a lift bag and it starts pulling you up? You guys all seen somebody with a lift bag like that? Well, that upward force is just like you taking a shipwreck, taking the metal and punching it that hard. And now you're inside of it. Would you want somebody punching the wreck or pulling on the wreck with all that force? That's effectively what we're doing by taking all that extra air in there and hotting it into a pocket. It's upward force there. So it's not as safe, and it damages things and silts the place out. So all that, yes. I could actually keep going on the whole night about the benefits of really diving, if you can't tell.
How about nitrogen buildup in the tissues?
Okay, that's a really good one. So I started off by saying who would like to go down and stay for 2 hours on the Spiegel Grove. Well, we all know from our tables or dive computers that you can't just go down and stay for that amount of time and then just come straight to the surface. Right? That's what we call no-stop diving. Is as long as you don't go past that number, you don't have to stop on the way up. Right? You get into what we call decompression diving, where you have a decompression stop, or somewhere along the ascent path that you have to pause your ascent, or just go up really slow before you hit the surface. The reason is because as you take a breath underwater, the nitrogen is compressed. You're actually breathing more nitrogen molecules than you normally do at the surface. At 33 feet, it's twice as many, and so on, the same math. And so your body, essentially, that nitrogen goes into solution. So it's no longer a gas bubble in your lungs. It's actually in your blood and your tissues and your bones and everything else. And so you're on-gassing nitrogen during every dive. So actually every dive is a decompression dive, but you've stayed within the limits so you can still go to the surface at any time. That's what no-stop recreational diving is. So on a dive for 2 hours at 100 feet, obviously you've blown way past what the table says you can do. So it's still going to be a decompression dive. The difference with a rebreather compared to open circuit is you're diving a constant partial pressure of oxygen here, whereas on a scuba tank you've got a constant fraction of oxygen. So if you know exactly what depth you're going to be at, then you could pick the best mix, and Dave or whoever fills tanks here could blend in your tank the best mix to give you the most time, right, before you get into deco, and the least exposure to nitrogen after you get into deco, so that way your deco is the shortest, for that depth. But when you go shallower, it's no longer the optimum mix. And a lot shallower is definitely not the optimum mix. It's So that's why open circuit tech divers will take multiple cylinders with multiple different gases. So that way, no matter what depth they're at, they're kind of close to the best mix. And as you get shallower, you can have a lot less nitrogen in there, and that helps with the gradient of nitrogen that you're off-gassing. But what a rebreather does is it's magic, right? So one of these cylinders is pure oxygen. The other one is some gas that you can dilute the oxygen with. Because as you get, how many people in here are a nitrox diver? Right? Have you seen what a nitrox course, the advantages of that would be? Well, what you learn in that is that the deeper you go, the less oxygen you can have in your mix, because your body's being exposed to too much oxygen, which is also a bad thing. So we can't breathe 100% oxygen at 100 feet. That's just too much of a partial pressure of oxygen, too much exposure of oxygen for your body to really like that. And it's going to have a seizure or some other issue that you're not going to want to have while you're diving. It takes away from the fun time of the vacations. So you dilute the pure oxygen with this other tank. And so the other tank has some gas that you can breathe at the deepest depth. Right? So if it's 100 feet, you could put, say, 32% nitrox in there. If it's deeper than that, you could put 20% oxygen and 20% helium in there. But it's some gas that you can breathe at the deepest depth. The cool thing about the rebreather is it's going to mix those two so that you have the best mix no matter what depth you're at. So just like you would plan for your best mix in your nitrox dive, you would actually just set it on the dive computer here, and it would add oxygen as it needs to and keep you at the best mix throughout the whole dive.
So it would be effectively, to visualize, it would be effectively if you strung a whole series of cylinders with richer and richer nitrox blends for your ascent. You breathed off of one for a few feet, and then you switch to the next one for a few feet, you switch to the next one for a few feet, because it's constantly adjusting the oxygen to maximize what it can push in you in oxygen, which is going to minimize what you're taking on in nitrogen.
And that's the only reason in nitrox we add more oxygen. Your body's not actually consuming more oxygen. We're just using the oxygen as a really cheap gas to put less nitrogen in the mix. On a rebreather, in this tank, you can put no nitrogen. Right? You can put all oxygen and the rest helium because it's such a small cylinder. You wouldn't want to do that, well, Dave may want you to do that with your big aluminum 80s or 100 cubic foot doubles or whatever. But you know,
Good for helium sales.
what do you charge? Like $2 a cubic foot for helium?
Yeah.
So instead of 100 cubic foot tanks, it's 200 cubic feet in there times $2. You know, you can spend hundreds of dollars on one gas fill. That helps pay the rent. Probably not for here, but at the guy's place that's selling the gas. I don't know who's making money in that game, but this little bitty tank, you know, you can fill that for maybe $20 instead of $200. So now you could take all the nitrogen out and put only oxygen and helium, and then the nitrogen loading just literally never happens. But that's sort of we call it heliox diving. So helium and oxygen, which is a little bit different. So to answer whoever's question that was, yes. The nitrogen is still a concern, but diving the rebreather, it optimizes that. And so you have much shorter decompression time, or you have much longer no decompression time.
So run something. If you're at 100 feet, 100 something you might know off the top of your head, you're down for 2 hours.
Mm-hmm.
What does your deep calm stops look like?
So like at 100 feet, and after this presentation, I've got a dive planner program that I can answer specific questions like that if anybody really wanted to know. But you know, if you're going to do, say, like a 100-minute long dive at 100 feet,
Right.
you know, probably just guessing something like 30 minutes of that would be deco. So you know, you would come up to a depth to where you couldn't go any higher, and then from that point, it would take maybe 30 minutes
Right, you'd
before
be
you could
starting
get back
30,
to the
20, 10.
Yeah,
Yeah.
exactly.
So since, like when we do a tech dive, we kind of plan out our deco.
Mm-hmm.
Since this is constantly adjusting Is there a way for you to play on your Deco? or
There
not
is.
really?
So what, do you use like a tablet version of the Deco software or just on your Shearwater?
Oh, either, yeah.
Yeah, so either one, you tell it you want a constant PO2 instead of the constant FO2 or fraction of oxygen, and it will calculate the dye profile based on that.
Okay.
It's very, very simple. It's actually simpler.
Yeah, that's
than-
just right the setup of the
Yep.
software, whether you're using fraction or
Right,
Yep.
PTO2.
Yeah, if you're doing a tech dive, you have 3 different gases, you have 3 different fractions of oxygen. You would still need those, but just to keep it simple, you would tell the
You give it the
computer
maximum
program what, well, not just the maximum, but what you plan to dive during
Right,
that phase
right,
of the
right.
dive, and then it would do all the math for you. Yeah. Okay, so how does it work, right? So there's a couple benefits, we can all agree to that. So you put this on your back, and it works sort of like a normal back plate and wing setup, right? It's not a jacket style where you got pockets on the side and it inflates. You've got a harness here that goes over your shoulders, and then a waist belt and a crotch strap. And that's what holds this back plate on. Now, when you're horizontal in the water, all the weight's just pushing down. So this may look uncomfortable, but the only time you ever really use these is when you're getting back on the boat, or off the boat. The weight's never really on these shoulder straps. That's why we don't have pads on them. You know, we sell shoulder pads to make it a little more comfortable, but diving in general, all this stuff's just sitting on your back, and if you have a wetsuit or a dry suit on, that's enough cushion to where you can't even feel that that's back there. Right, so you got the harness and the back plate, and then sandwiched between this piece of plastic or metal back here are 2 other things. And one that you're familiar with, and it's called the wing, right? And so when you're on the surface and you need to float, you breathe into that, or you press the inflator button, and it's kind of like a life jacket. It's an inflatable life jacket that helps you float. Right? Who dives a back plate and wing already? Right?
A great number of people.
Most of
who
you.
are big
So you're very
proponents of
familiar with
backplate
that.
systems.
The thing that's sandwiched between the wing and the back plate, though, is what we call the counter lung. And think about that just like an external lung to your body, right? So if you had a bag that you were breathing into, right, that bag would be the counter lung. Because when you breathe back in, you're not actually getting any extra gas, but you're not losing any gas. There's no bubbles coming out. So this is effectively just like another wing. It's just a different shape. And it's literally made by the same company that makes the wing. And it has the same Cordura cover for it and everything else. So if I took this apart, you would think that it was a wing to some weird looking, you know, backplate and wing system. There's nothing fancy about it. It's all the same stuff. But attached to the counter lung is this black loop here, right? And so this rubber loop, and Dave's there has a cover over the rubber loop. In case he's inside of a wreck or a cave, it's less likely to get this cut. But it's effectively just a rubber hose that you're breathing through.
And if I may point out a difference that runs through the rebreather industry is the location of the counter lungs. And it has everything to do with your breathing effort, whether if your counter lung is below you or above you, whether it's easier to inhale or exhale because you're moving air from one altitude in the water to another. So my rebreather here has front-mounted counter lungs. So they're on your chest. Very easy to inhale, harder to exhale because the pressure is greater on my chest to push out. Scott's are on his back, which makes it very harder to inhale because he's pulling the air from a lower pressure state to a higher pressure state in his lungs, but easy to exhale. Some companies make over-the-shoulder ones, which kind of split the difference, but it becomes a style thing at some point there. It is where your counter lungs are. But I just wanted to point that out, that this is the opposite of the style of the subgravity it's chosen.
Yeah, if you were in the water with your fins back here and your lungs are at one depth, your entire lungs are at one depth, if the counter lung can be at exactly the same depth as your lungs, breathing in and out is going to be exactly the same as it would be in this room right here. So what Dave's talking about is if it's even just a couple inches below your lungs, it's harder to breathe out and push downhill, right? But it's easier to breathe in because you got a couple inches of hydrostatic pressure that's pushing up into your mouth. Now, we'll talk in a minute about different types of rebreathers. There's a whole other type called a side mount rebreather, and it's on your side. You guys ever seen a side mount diver, right? Two clips and then a bungee cord, and you know, nothing on the back, just on the side here. Well, the whole rebreather could be on the side. Well, if the rebreather's up 10 inches, you have a lot of pressure to pull that back downhill. Or if it's down below you, you have a lot of pressure to push down into. Right? So that's why you'll hear different types of counterlungs. So not to get too complicated about it, but just that's where they're at and that's why they're there. So the way they get air into them, though, let's go back to the beginning. Everybody's familiar with a mouthpiece, right? And a second stage, right? So effectively, if you took this off, this is what you guys are used to diving, right? This is just a mouthpiece and a second stage and a hose that goes around to your tank. It's that simple. If you want to breathe off this second stage, this goes up, which is stopping the flow of gas going through the loop. And I can literally jump in the water with this right here without that even being hooked up and go on a dive. So you have that as a backup. So worst case scenario, you just rotate this, and this is what we call a bell out valve. So we belled out off the rebreather, and it's this valve here that allows you to just breathe normally like you're used to.
You're breathing pure oxygen.
You're breathing what's in that special tank.
Diluent tank.
That
Which
diluent
could be
tank,
helium.
which could be helium, sure.
Which is not good.
Well, it's going to be helium and oxygen. It's going to be something that you can dive
Okay.
no matter where you're at in the water. In general, yes.
Right,
Okay.
when we're selecting our gases, whether we have it in our rebreather or whether we have an auxiliary cylinder hanging on us, we always have a gas that you can breathe at the deepest part of your dive. That's important for bailing out, is that I know I can bail out. That's why a technical diver that's carrying 50% oxygen and 100% oxygen, those aren't bailout cylinders because you can't breathe them until you get to the required depth. So a rebreather diver needs to have something. If you've got some extreme gas in your diluent cylinder, then you would need to carry a bailout cylinder, a
That's why you
separate
have
cylinder.
the side bottles when you were diving, because those
Yeah,
are your,
Right,
your bailouts.
Yeah.
exactly.
And what, you have one too, right? So you have a
Yeah.
second stage, yeah. So there's some rebreathers that don't have this second stage. It's just an on-off, which will close the mouthpiece from flooding the unit. So you would close it and then just literally switch to the second stage and you go straight to that tank.
Like an octo.
Yeah, exactly. All right, so before I put this back together, the magic in a rebreather though is that we have two one-way valves, right? You know, like on a lot of snorkels, when you blast clear a snorkel, it goes through a one-way valve at the bottom. And then when you inhale on the snorkel, that valve closes. This is just a large one of those. And they're pointed in different directions, right? So this one only allows the gas to come in, but this one, when you exhale and you try to breathe in, it closes,
Yeah.
right? So you call it a mushroom valve
Mushroom,
or a one-way valve, and it's just a thin little piece of rubber there that makes this whole thing go in a circle. So before the dive, you would inspect that to make sure there's no bugs or sand or anything else in there. Ice, we were talking about cold water. One time I had water that was frozen in there, and so when you breathe in and out, gas just went right there, and there was like an icicle. So you've got this that connects, right? So when you exhale, it's going to go in this direction because of that one-way valve, and then into this counterlung. We call that the exhalation counterlung. So if you have any water in your mouth, it's going to go down through here into this counterlung, and then you can dump it out. Or on Dave's, it's even easier because out of your mouth and then down to here, and then that's the lowest point, and it's really easy to dump.
So if you're diving in extreme cold temperatures, the air is warmer, so that would help, but it's also moisture. So can you dive in like 32 degrees or?
Oh yeah, it's warm air at 32 degrees.
Yeah.
But the
But if you leave
the
the-
moisture isn't going to make it freeze?
No, it's warm inside the loop. So the example I just
If
gave
you
was,
stop breathing, yes, but as long as you're breathing,
yeah,
you know,
exactly.
you're refeeding with warm air from your body, but you're also getting the advantage, as you pointed out, the exothermic reaction of the CO2 retainer, which is heating the air up. So you're getting more than 98.6 degree air coming back into you.
Yeah, I gave a bad example. That was actually on a second dive of the day. So we've been sitting on the boat, and 30 whatever, below 32 degrees, and the water that was in there from a, you know, loose lips and a little bit of water came in there, or just condensation, actually froze between dives. And so that's why it was there. But I knew it was there because I did a pre-dive inspection. Right? So then it goes out of that counter lung into this big canister in the back. Right? And then this is another difference between a lot of rebreathers, and that's when the high CO2, low oxygen air goes into this contraption. There's two different ways that happens. One, it could just go into the bottom and then go straight up the axis of this and then out the top. We call that an axial rebreather. On this design, it actually goes in the side and goes through the radius of the canister. We call this a radial scrubber design. So the gas from the exhalation counter lung goes in here, sort of floats around, and then gets pulled through that much absorbent, right? And then up through the middle, and then across the face of these three sensors here. And this is just like your nitrox analyzer or oxygen analyzer that you have out back there. But there's three of them. So that way, if one's wrong, you have two more that are hopefully right, and you have some voting logic there. These are connected by a wire, which then comes down on your handset. So at any given time, you know how much oxygen you're breathing by these three oxygen sensors. And we're doing this dive, and you got a little bit of current, and so you're consuming more oxygen, right? Or you're just taking a picture of a fish, you're also consuming a little bit less oxygen. And so there is a hose that's connected to the oxygen tank that comes in the top here. It's kind of hard for me to show. But that's then connected to a little bitty hose and what we call a solenoid, which is a valve that opens and closes electronically. And so the computer will actually tell it, hey, oxygen's a little lower than where Dave wanted to set it, and so we need to add some more. And so he changed his set point before the dive and told it what partial pressure of oxygen he wanted to be diving. And so the computer actually opened up the oxygen tank and put a little bit more in there and waited a few seconds and then put a little bit more and waited a few seconds until it got back up to the point that he wanted it to be set at. So you have a set point on here, and that's what you do the whole dive at, basically.
It seems, sorry, I was just going to ask what the exact reaction that's happening with the CO2 is. I don't know if you know that, I'm just curious.
Yeah, that's getting a little bit out of
Okay, that's fine. That's fine.
But all scrubbers use the same material, same as on submarines, and it's a calcium carbonate that has an affinity for carbon dioxide molecules. So these are boxes of it right here, and if you take it out and take the wrapper off of it and just leave it in this room, it will eventually expire just from grabbing carbon dioxide molecules in this room.
Okay.
So that's part of the whole maintenance of the system. There is not exposing your desiccant or your thank you, unnecessarily, and when it's time to change it out.
Gotcha.
Does yours use a sensor? Do you have a temp stick in yours?
It doesn't use a temp stick. It actually has a CO2 sensor built into it.
So
three oxygens and one CO2.
So on this unit here, he has a CO2 sensor actually built into the electronics. So it's picking up CO2 breakthrough. When your chemical is no longer able to absorb enough CO2, it sees the CO2 breakthrough and it alarms.
Gotcha.
Some units use a temperature stick, and they're generally axial loading units. And the temperature stick is a device that senses what the temperature is at various spots on it, and the reaction is exothermic. So when you first load your chamber, the reaction takes place at the very front, which is the bottom in my case. And then as you use it, and that's exhausted, the reaction starts moving up. And so your temperature stick is like a gas gauge on your car. You know where you are in your chamber, and you know how close you're getting, to the end when you need to stop using that.
Gotcha. Thank you.
Is that a weekly change, or is that a daily change?
That's how often we dive.
Yeah, that's like diving down a deep hole here. So let's move on to talk about how this works. I mean, you have that system, but then that's vulnerable because if the absorbent, has a breakthrough or like a gap in there, then it doesn't really matter what the temperatures are. The gas is always taking the path of least resistance. So now you have high CO2, and it doesn't matter what the temperature is. So you think you're safe, but you're actually not. This one has a fault because this is actually measuring CO2 as it crosses the face of this, but it isn't perfectly reliable either. So it can give you a lot of false positives, which would then make you want to end the dive, even though you just had high moisture content right here. So yeah, we can get into the chemistry of all that. That's why it's a 6-day-long class. Some of us are talking about it.
And Undercurrent just had one where they're working on a waterproof PO2 sensor to
Yeah.
eliminate that problem.
Yeah, these have a hydrophobic membrane across.
Well, this is something you put on you, so you know what your PO2 is. It just came out, the most recent Undercurrents.
Oh, so you're saying like during the dive, you know what your oxygen saturation is.
Right,
during
of
the
you.
dive.
So
you would know if you had not enough oxygen, but you wouldn't know if you had CO2 poisoning, which is effectively what's happening when you have high CO2. And CO2 is what's making you want to breathe, right? So if you start breathing rapidly, that could be high CO2. A few other things too. I don't want to scare anybody away from it.
What's a typical set point?
Like 100% oxygen would be represented on the computers at 1.0.
Right.
So a lot of people that do a 2-hour dive will dive at like a 1.2. If you're going to do a 5 or 6 hour long dive, it would be a 1.0. If you're only doing a 30-minute dive, you could dive that for 160% oxygen. So it's all about continuous oxygen exposure for one dive, or for also accumulation over multiple days of diving. All those are factors that you have to consider. But like 1.2 is a very typical thing we use in training.
Right, just for a reference, right? This is our laboratory reports on our gas analysis, which we do every 90 days here. In compliance with PADI standards, we send gas samples out to an independent laboratory, and they process it. Our carbon dioxide in our gas that we pump into our tanks here is 486 parts per million, almost non-existent. And the maximum specification limits for the gas we are qualified for, which is grade E oxygen compatible air, is 1,000 parts per million. So how does that relate to percentage? You can get your cell phone out and do the math here on ppm, but
It's a very small
it's
percentage.
very, very small amounts is what we have in here.
And when we actually calibrate the CO2 sensor, we actually use 400 parts per million as part of the calibration process, because we assume that's what's just ambient in the air. So yeah, it's a very small percentage, but double that, your body knows it. So, all right, so this is how it works, right? So the gas comes in, flows through the radius of this unit, or in the other unit, it would flow all the way down to the bottom and then all the way back up through. So if you consider like breathing through your shirt, right? That's a little bit harder. Breathing through like a whole folded up towel, right? Which is about that much. Or if there was like a stack of towels and you had to breathe through the whole thing, right? Obviously that's gonna have a factor in the work of breathing as well. So that's why we have different designs, right? There's also different shapes and sizes of the stuff that we pack in here. And there's also pre-packed that you don't have to touch at all. You just take out of a plastic bag and throw it in there. So all those things have advantages and disadvantages. But in general, you need something to bind with the CO2 to pull that out so that way you can keep breathing. And then you need something to inject oxygen back into this loop. And these units have a solenoid that opens and closes and does that. They also have a valve here that you can manually press, right? Just kind of like a BC inflator. I'll show you when I get to the front. That you can also, anytime you want, add oxygen to get your readings up higher.
Now, isn't there an issue or danger of the sorbent getting wet?
Sure. So if it gets wet and then it's in the so if it's wet and it's liquid, it can then move around inside the unit where the granules can't. Right? The granules are caught by this mesh screen. So you're never going to breathe in, you're never going to eat this stuff because it's all contained here. But if you have water in here, the water can make its way back to the mouthpiece.
That's a flooded loop.
And then it's a caustic water that you're now breathing, and that does some really not good things to your body, right? So
what stops it from doing
Seal the unit.
well,
Design, basically. I mean,
yeah.
when you exhale, again, I referred to my machine. On my machine here, we have a thick sponge at the bottom of the chamber, which is where the gas comes in, which absorbs your breath, right? Plus, you've got the counter lung that we're draining various times through the dive, right, which is all spit. And when you come up at the end of a period of diving and open this up, you take that sponge out, I mean, it's like, you just soaked your kitchen sponge in the dishwater, right? I mean, there's that much moisture from your body in there, and it's all inside the loops, and it's inside the lungs, which is, why I'll talk about maintenance and all that, but I mean, it's a tremendous amount of moisture that you put out into the system.
Yeah, so during the dive, you can de-water the unit. So if you sense that there's some water in there, or like you get really excited because a whale shark swims by and the mouthpiece comes out and water goes in there a little bit, on Dave's unit, it's extremely easy. It's literally, the water runs from the mouth to there, and you can just dump it. On this unit, it's kind of behind your back. So it's got to go all the way down the loop, and then all the way to the bottom of this counter lung, and then you can dump it. But if you think about that, the whole counter lung pretty much has to fill up with water, which is huge.
Yeah.
Like liters of water you would really need in this thing to then fill this area and then get all the way back around to your mouth. So I'm not saying like it would take liters, but it could if you stayed in the right orientation. You could load this thing up with liters of water before it became a concern. You could also put a couple ounces of water in there and then move your body in just the right position to work it all the way through and get it back to the mouthpiece. But that's just about impossible. So it's a concern, but it's, depending on the design, almost irrelevant. And that's something you learn in the training course too. All right, so let's get back to taking a breath in, right? So this pulls the CO2 out, it goes across the face of those sensors, then the computer, if it's below the set point, will inject some oxygen. It injects it here, and then you're going to breathe it through the inhalation counter lung, right? So it's going to come through this loop and then fill this up before you are ready to take a breath in. So that's why you've got two, one to exhale into and one that kind of fills up and you inhale from. And then it comes back into the mouthpiece. And then you do it over and over and over and over again. Now, somebody mentioned earlier about as you go down, does it get harder to breathe, right? Does it create a vacuum? Because the volume of gas just got cut in half in that 33 feet. So you have only half a breath, which is true. So you have to add something back into it. And you can't add oxygen at 100 feet. So you add some diluent. And this has what's called an automatic diluent valve. And it's like another second stage. So just like here, you've got a diaphragm in there, and when you breathe in, the diaphragm presses a lever. That lever opens a valve. That's how the second stage works, and you can take a breath. There's also one built into the loop itself. So you'll never get a vacuum because there's a second stage built in right here with the diaphragm.
Adding pressure as you go.
Adding diluent because you can breathe that at any time.
Not pressure, volume.
Thank you. Got it.
Right?
Yeah.
It's all about volume going up and down.
Fair
Yep.
enough.
Or you,
Pressure is means the need
Right.
for greater volume.
Correct.
or you want to add some yourself. And so you don't have to draw all the way down to a vacuum. You can actually press this manual add valve, or we call it a MAV. And that's just like your BC inflator. So just press that and inflates the wing a little bit.
So if you're having a tough time breathing, you can just, if you feel like you're struggling to get air, you just
Sure. Yep,
and
It
do it a little
inflates the lung
it does. It inflates the lung. That's exactly
Cool.
right.
with
With the diluent.
the diluent.
Now you could also inflate the lungs with oxygen, right? So it's got one on that side as well. So now you're your own nitrox mixing station, right? So say the batteries went dead, or the solenoid quit, or something like that. You can still dive the unit manually by pressing a little bit of oxygen and a little bit of diluent. It mixes it out, and you can look on your sensors and see exactly what you're breathing. You can even use your computers. And you know that if you take a breath in, say you got 32% in there and you're at 33 feet of diluent, that's like 64% oxygen in there. And when you exhale, it's going to be 60%. And you inhale and exhale again, it'll be 55. You know, you can take several breaths off of it. So you don't even need oxygen sensors. You can dive the unit with no electronics in it. And that's another dive that we do. It's called semi-closed. So you would flush the unit with diluent, you take a few breaths, and you exhale that, flush it again, and you take a few breaths, and you exhale that. And so if you had an aluminum 80 that you were flushing this with, you could extend that aluminum 80 by however many breaths you're taking. So it's kind of based on depth. But if you take 5 breaths and then flush it, you just extended the life of that aluminum 80 by 5 times. So there's a lot of magic that goes on in here, considering the limitations that we have with breathing one single aluminum 80 or the single first stage and 2 second stages. There's a lot of redundancy here. However, at any given time, you planned your dive so that this whole thing could get a cut in it, right? Or just a shark eat it or whatever. And it totally floods, and you don't want to breathe the caustic water solution. And so you carry with you, like you guys saw in the video, or kind of like what he's doing here, side mounting some type of bell-out tank, cylinder, and a first and second stage. So that means at any given time, you could just close this up and switch to your bell-out setup, and then in the dive. So you can take that aluminum 80 and your hose, and then just swim back to the boat, and then figure out what happened here.
What are you using for your wing, for inflation of your wing?
That's a great question. Both of these systems are set up to work off the diluent. If you needed to, you could run all that extra stuff, your dry suit, your wing, your bailout valve, all of that off of an external cylinder. And people use quick disconnects for that. So that way, if you needed different gases for different depths for your bail out, you just switch quick disconnect underwater. That's a really common thing that to have set up. It's not a common thing to happen. These things very, very rarely ever break. And they usually break only because people don't maintain them. Or, I don't know, that's actually probably the only reason. I mean, these things are so well tested that they're made pretty fault tolerant from the engineering and manufacturing side of things. And, you know, they just literally never break or have a problem as long as you take care of them and go through the right procedures. Right? So, how much does it cost?
Just one quick question. So you
Sure.
It's like you don't really want to take your mouthpiece or regular out without closing it, right? So you don't want to take your regular out to
You have
avoid
to
getting
close
water
it.
in.
You just have to close it first. So that valve that's normally like this, you just close it, and then you can take this out
Right.
and put it back in and exhale, and then open it, and then no water gets in the loop. Yeah.
When you exhale, it's the same
Yeah,
exhaust
yeah,
as the second stage, so you exhale your breath out and push the water ahead of it, and when you flip it open, you're dry.
Okay, so different manufacturers have totally different ways to sell these. The way Subgravity chose is you go to this website and you spec one out, and you're effectively buying it from an instructor who's then going to train you how to use it. You guys are going to have Joe Stellini here in a couple months.
November, yeah.
You know, his rebreather company has a different model. It's like just buy a regulator from the store, and you know you could stock them in a box here. But they make a lot more of them, and they're more of all the same. Whereas this is a more customized setup, I guess you could say. We also sell these complete. So, you know, this is $10,195 for generally this setup. And you could go through here and select things like what color cylinders you want, what size. You know, if you want what color wing, what type of harness, what type of extras you want here with it.
So is that a base price or is that a?
Yeah, so it's kind of a base price, but it includes everything. So that price includes everything you see here.
All the options.
Yeah, but you may want like a nerd, which is a near eye display, a Shearwater nerd that appears like a Purdick stop computer that's right there at your eye. Or you may want 2 of these, or you may want only 1 so you have less failure points. So there's a lot of philosophical preferences that go into these. Also material type. So if you looked inside of each one of these, you would notice that this aluminum one, that anodization on the inside because of that caustic solution has been eaten away. Whereas this Delrin one or plastic one here, you look inside and it looks brand new. You know, this unit probably has 1,000 hours on it. So that's a little bit different. Also the weight, right? So this one's shorter, so it's more of a travel version. Even though it's a 5-hour unit instead of an 8-hour unit or 6-hour unit, then it's a little bit lighter and smaller for travel. You can also put smaller cylinders on this. So this is a 3-liter cylinder. You can have a 2-liter cylinder that would fit really well in here. You could get a aluminum or a carbon fiber backplate instead of a thick, heavy steel backplate. So these are all different options. Maybe the shop doesn't service dive right, so you'd want to buy an Apex rag, or the other way around. You're in Florida and the shop only services dive right, so you'd want those first stages. So that's why there's different things in here, but in general, it's about a $10,000 initial purchase.
So if you're diving that in a dry suit, what's the buoyancy characteristics?
So I've actually installed little weight pockets on the inside here, the same like the Subgravity trim pockets that I think you guys have, and so I can put like 4 pounds on each side. So that's sort of worst case scenario.
It's got steel cylinders on there as well.
Me in a dry suit with steel cylinders, an aluminum backplate, adding about 8 pounds.
One of the features of a rebreather that I might have missed if you had mentioned it here is buoyancy control. The counter lungs are counter to your lungs. And so when you exhale, the volume you are giving up with your chest is being taken by the counter lungs. And when you inhale, the counter lungs deflate and your chest becomes bigger. So once you have dialed in your buoyancy with the rebreather, you are perfectly balanced through the entire dive, provided you stay at that depth. If you change depth, then you need to add or reduce volume. It's in your lungs, become shallower, your counter lungs are going to get bigger, you need to dump them. If you go deeper, you need to supplement to make them right. But you always have one breath. It's either inside your body or outside your body, but it's the same. So a rebreather diver, typically on a dive, driving around coral heads or things like that, will come up to a coral head, and a open circuit diver will say, I'll just take a deeper breath, right, and I'll go over that, and then I'll exhale, and I'll get back on it. A rebreather diver is going to go sideways around it. Because inhaling or exhaling anymore isn't going to make any difference.
So some people say it's hard to learn to dive a rebreather because your buoyancy is completely different, but it's just a different way of diving. And you figure that out in the first couple hours of diving in the class.
Can you fine tune the buoyancy with adding air to your counter lung?
You can, yep. So the goal is to keep it at the minimum volume possible in there, right? So when you take a full breath, it bottoms out the counter lung. So that way you don't have a lot of extra gas. Just like you shouldn't dive with a lot of extra, you shouldn't dive overweighted, which means you have a lot of extra volume in your wing, because as you go down, you got to adjust the volume in your wing. If you were properly weighted or at the least amount of weight on, you have the least amount of lift in there. So it's just less maintenance as you go through the profile of the dive. All right, so $10,000 to buy one. You can buy used ones every now and then, but even a used unit of this brand goes for like $7,000 or $8,000. So not a huge, they're not like driving a car off the lot and you lose half the value. Other rebreather companies, maybe the new price is somewhere between like $6,000 and $12,000. So this is kind of in the middle, but on the upper end. This would be like the Volvo, Mercedes of cars. It's not a Ferrari, but it's definitely a higher price tag than what like a Ford or Chevy would be, right?
What makes the price difference? Sorry. So where's the money?
Yep. So other manufacturers that have less expensive units, they're going to have like injected molded parts, whereas this is all either machined Delrin, like the BOV that I was talking about, that's one solid piece of Delrin that they machine out. That's different than having basically like an injected molded, less expensive plastic first or second stage. Yeah, I mean, less electronics is going to make a difference. The more shear water dollars you spend, just like any other type of diving, the higher the price tag is going to be. So yeah, that's mostly it. The manufacturing cost and the scale, right? So like the Hollis Prism, they sell a lot more of those, so they're able to sell them at a smaller or less price. But to manufacture that many, a lot of the parts are manufactured in a process that's manufacturing instead of more precision, differently engineered things. So after you buy it, you spend $10,000. Then every year you have to service it, just like a second stage and first stage regulator. You guys spend what, like $30 a stage or so, plus parts. Same thing here. You can send this back for about $250, including parts. They'll service the whole unit. So every O-ring, everything that needs to be cleaned, they'll fix that. So that's one cost. Now during the dive, you're gonna have to spend some money, right? How much do you guys charge for a nitrox fill? 15 or 20 bucks?
15,
Yep. So if you're gonna do 2-tank dive at $15, it's $30 in gas. Whereas if you take a nitrox tank on a rebreather dive, you're not gonna use it. Because unless this thing breaks, you come back and it's gonna be full. So we don't really even consider the bailout gas as a cost. But you'll really just be using your oxygen. So a lot of shops charge like 50 cents a cubic foot.
Yeah.
So this is like $7 in gas that you would use maybe for 4 hours of diving at any depth. $7. Pretty.
So when, for shallow dives, 60 feet or less, rebreathers are somewhat tough to justify if that's your range of diving. When you start diving deeper than that, then it makes all the sense in the world to be looking at a rebreather, from volumes of gas you have to carry to available amounts of bottom time, everything that goes along with it. But if you're doing 30-foot reef dives in the Florida Keys all day long, that 80 will last you an hour and a half. That's 4 hours, right?
And then you need some of the CO2 absorbent, and so this is about $3 or $4 a pound. So if we said 1 pound lasts generally an hour, that's $3 or $4 an hour that this stuff costs. This is unique though because you can't really reuse it, right? So after you do a dive with it, you can't like save it and dive again next summer when you go to the Florida Keys.
You see those guys put them in plastic Ziploc bags.
You can, right? So if you're going to dive again tomorrow, you could take a dry bag and put this in. But what you're really trying to do is the moisture not drying out, because it's kind of like kitty litter, right? So if it clumps up, then you can have breakthrough in there. So doing like 5 one-hour dives is way riskier than doing 1 5-hour dive, just because of the drying and non-drying that this thing goes through, the cycle that it goes through. It's just not as safe that way. But that's generally the cost, right? $3 or $4 an hour for the Zorb.
So you could put in only 2 pounds?
You sort of can. I've got some flyers here that if you guys are interested, you can pick up. This one here talks and shows the different sizes of canisters that you can get.
So do you throw the canister out when you're done with it? You don't refill the canister?
You empty it and then refill it.
Oh, you do? Okay.
Yep, exactly. Now,
So you're using a manual, so you're not using a pack there.
yeah, this is a packed setup.
Pre-pack.
No, this is not pre-packed.
No, sorry, it's manual pack,
Yeah.
right?
Yeah, so
So when he fills that, he needs to take time and make sure that he's got a good even fill, that he's knocked all the loose parts out. So you'll see people making love to their canisters at a technical diving place there, getting all that shaking and everything. But it's very important because if you have a short fill and you go on your side like a diver, you'll have a channel right up the side where it's not packed with fill, and therefore create a bypass.
yeah, so you see this plastic? I can't breathe through the plastic, but I can breathe through the screen. And so the plastic and the screen goes down to about here, and that's solid. So if I only fill this halfway, and I took a breath through there, it's going to go through the path of least resistance. And it's not going to go through the material, it's going to go through the air here.
But they sell shorter ones.
So if this gets shaken and the stuff vibrates together and then creates a gap up here at the top, we'll bypass the absorbent and you'll just be constantly increasing your CO2 because it's not really pulling any out. They make different sizes, right? Obviously this is a different size than this unit. So
Well, can you put a shorter, can you put the shorter unit in the
you
bigger one?
can,
Yeah,
yep. And you just put a spacer at the bottom, so it's a solid Delrin spacer, and that's how that works. However, the pre-packed ones is super interesting because you can use a pre-packed canister that you can pull out and say, I dove on this for 1 hour, and put it on the shelf, then put a new one in for the next day, and then whenever you've got like a 2-hour dive to do, you got 2 hours left on this one, you can put that one back in there, even like a month later. And that will close these up and save them for that. That is one advantage, that you can save your Zorb by doing it like that. You can't save this. You actually pour it in there, and then when you pour it out, it'll never get put back in there the right way. So whenever we dump this stuff out, we never reuse it.
So say you're 2x for a day, but you want to spend an hour on each. You're not changing between those in a day.
So basically, you've got a timer on here, and it'll
Right.
tell you how long you've used this pack, and based on the size of it, there's a manufacturer.
Well, I'm saying you have enough
recommendation.
time in that one. You're saying that does 5 hours.
Yeah, exactly.
So if you're doing, at what point do you need to change out as opposed to let the sealed unit just stay sealed?
When the
Is that a
timer,
day?
yeah, when the timer runs out. So it depends on how long you're diving.
No, but
No,
I'm
I think
saying,
his question is, I do 2 dives a day, like let's say an hour dive, right?
Right?
And then take a 5-hour break in between, right? Because I have other stuff to do. Is there a time limit how long I can keep everything the way it is?
without
Before I
breaking
need to-
it
Yeah,
down,
so could you
reloading.
do 2 hours this weekend and 2 hours next
Well,
week?
no, even in a day. I mean, can you do it a week apart if it's sealed up? Is it?
Yes.
Okay, so as long as you don't open it up.
Yeah, this is getting into,
Okay.
an interesting debate here.
The general consensus is you can dive all day on the same as long as you don't exceed the limits,
Well,
right?
right, the limit's the
And you
limit.
can dive a
regardless.
weekend. So like we would go to Dutch Springs and dive on Saturday and dive on Sunday on the same pack.
Absorbent, right.
Right, because we had 5 hours of absorbent in there, so you're not going to dive 5 hours, and you could dive both the days, but you would never carry it to the next week.
Okay, that's what I mean. So you can go
You can only go
1,
to
2
the
days.
limit.
That's fine.
That's what a lot of people will say, because we know that works. There's also people out there that will dive it this weekend and then in a month from now. And they're still around to talk about it. So it's based on what the manufacturer recommends
Okay.
versus what people do in real life versus what we do in the training agencies versus what you would do with your dive buddies. So that's where I'm saying there's a range of
But a
metrics there.
manufacturer, 48 hours is an acceptable time.
All
limit.
manufacturers would say that that's okay.
Fine.
There's also some research coming out to say that longer is okay as well.
Okay.
So,
But essentially, if you go on a week with one of these rebreathers, you can pretty much expect to either repack or put in a pre-pack every 2 days, depending a normal
depending on how long you
time.
dive.
Yeah.
So that's going to change, if you guys got one of these, it changes the way you think about diving. Because you would never jump off the back of the boat, go dive for 30 minutes, come back up, talk about what you saw for an hour, and then go back and dive for 30 more minutes.
Right, you just don't dive
Right.
that way.
You're going to do 1 dive a day,
Yeah.
basically.
So like
1 dive a
Portuguese
boat.
dive, not Portuguese, horizon divers, their typical double dip dives, they go out to Spiegel Grove and they tie up for 2.5 hours. They
You
go
would
to
just
the
do
Eagle
the
and they
whole
tie up for 2.5 hours, or to Dwayne for 2.5 hours. And so if they got rebreather divers or technical divers on the boat, 2.5 hours
Right,
before we
they-
pull
they're-
the hook,
they're
right?
under the water the
If
whole
you got
time.
recreational divers, do a dive, come up, hang a little surface on the wall, go back down and do a second dive.
Got it.
You know, it doesn't matter, but that, again, that's the way the operation thinks, because they understand technical diving.
Right.
A recreational operator, you know, is gonna be on this ball for 1 hour and then we're moving to another ball. If
Right.
there's no advantage of being able to stay down longer because we got 1 hour.
But if you think about what's harsh on your body
Your
during a
surface
dive,
interval, et cetera.
Yeah.
you're compressing as you go down, and then you're on-gassing, and then you're decompressing on the way back up. And that's the most dangerous part. If you go up too fast and you decompress too fast, So if you can do that one time versus 2 or 3 or 4 times in a day, that's healthier on your body. So it's just healthier to do one dive. You're only getting back on the ladder one time. You're only putting the dry suit on and taking it off one time. So like all those human factors of where you make a mistake, or just the physical factors of like it's dangerous being on the surface in 4-foot seas with a, multiple ton boat here and a big metal ladder here, that's the most dangerous part of the dive. If you can do that one time versus 2 or 3, then that's why diving a rebreather for a long bottom time has an advantage.
So I should see if my health insurance can pay for that?
Absolutely. Absolutely.
Like the gym membership.
So it's a different, it's definitely a different headset though to do a 2-hour dive. To be underwater, it's different headspace to be underwater for 2 hours instead of, a 45-minute.
Well, you're not.
Keep it nice, stay warm.
You're not on the wreck for 45 minutes though. You may do a
Right,
45-minute dive.
I understand that. And then the other question is, you're telling me it's warmer to breathe, so I'm just assuming that you're not going to freeze in 2 hours.
Blue Heron Bridge, we do a 2-hour dive all the time.
Yeah.
Now, but it also, the whole mindset and the whole preparation,
changes.
when you start planning for long dives, it's just like technical diving. The most dangerous part of the dive is at the end when you're cold and chilly and you want to cut this time short, cut your decompression time short or whatever, that's the dangerous part. So, immediately you start thinking, hey, this is going to be a long dive. Yes, the water's, 78 degrees, but that's still 26 degrees colder than my body is. Or 16, whatever I got to do the math here. But nevertheless, so I need a thicker wetsuit, so I need a 5 when everybody else on the boat's wearing shorties, right? Because I'm going to be down there chilling out, not kicking hard. They're going to be benefiting from the recycled heat from the machine, but nevertheless, you're being exposed to, a body of water that's colder than you.
I think what you're saying is your first dive with it, you don't do a 2-hour dive.
No. Baby steps.
Yes, exactly.
You don't. So let's jump down to training, because that kind of ties all this together, and it's building the confidence to take this unit and actually go do a dive with it. Knowing the responses on what to do when something isn't working just right, and then actually how to do dives differently than what you've been trained to do before, right? So during the class, a typical class, you would get 7 hours of open water time, at least, minimum, and 60 minutes in a pool, or confined water, and a whole bunch of classroom time beforehand. So you're talking about at least a week-long course of learning this particular unit. Not rebreather diving in general, but this particular model of a rebreather by this manufacturer. If you wanted to dive that one, and you were already certified on another unit, you'd have to dive at least 4 hours in the open water just to orient yourself and do a crossover. So that way you learn where the valves are and how the computers work differently and just how to build it, how to maintain it, all that stuff takes time. So now we're talking about a week-long course, and you only have 3 students in the course. That's the maximum. So typically rebreather classes are like 2 students, and now you got an instructor who's also wearing a $10,000 unit. So you can see there's going to be a decent sticker price on this experience, right?
Good place for a heist.
So what do you guys think a typical beginner 1 week long rebreather class would cost?
2,000.
Some great guesses, actually. So that's what I charge for a class. If you're going to do other things, you can add on to that. If you're going to rent a unit, which is an option with some instructors, maybe like $100 a day to rent a unit. Or if you're just crossing over, it may be as little as $1,000. Even though you're taking the full 5-day class, if you've already got a unit. So it's somewhere in there. Depends on where you go in the world. Almost all Subgravity instructors, the page that I showed you in the beginning, everybody on that, we're all supposed to be quoting $2,000 for the beginner class. But the beginner class doesn't give you any decompression time. So you still are restricted to those no decompression limits, right? So if you consider every training agency has lots and lots of charts that have all the classes put into a little flow chart here. The rebreather world has the same thing. So you start off with basically air in the diluent and no decompression, and then you can add decompression, and then you can add mixed gases, And then you can add gases that you can't breathe on the surface, which is what somebody asked earlier, because it has less than a breathable amount of oxygen in it. And then you can do other things like go into a cave. Those are rebreather specific courses you can take. And so there's a lot of other classes, and these all add on, you know, $1,000 to $1,500 per course, because the instructor's wearing expensive gear and using expensive stuff, and you're usually in some, you know, environment that's more expensive than just going to the quarry, and it's a limited number of people in the class. So that's why it's an expensive experience, not because we think that we're better and this is the best class and you should pay more for it. It's just an expensive thing to do. Right? So for me to be a rebreather instructor, I had to buy one of these, take that same class for $2,000, along with all those others, and then go back and repay for all of those on the instructor level. So, you know, I'm in like 50 grand to be able to teach, you know, the first class of students. So that's where it really builds in the economics of having to charge that much. But after you know, take that class, then crossovers to other units are less expensive, time-wise and money-wise. Or you could just go and never take any other class but the first one. I mean, you don't have to take these other classes and go deeper. You don't have to go into a cave. There's a lot of people that will buy a rebreather just to go out and take National Geographic quality photos on a 20-foot deep reef. You can take pictures of stuff that you literally didn't know existed, because when you jumped off the boat, banging the drum all the way over to the reef, they heard that and you never got to see them. And so a lot of rebreather divers will jump off the horizon boat and be the first ones down in the wreck and see, you know, schools of sharks and see the turtles and the rays and things like that, and literally have to take a picture of them, because no one back on the boat will believe that those things were down there because they didn't see them. So there's been many a rebreather diver have to prove what they, you know, saw. It was so exotic that not even the boat captain believed there was a manta down there off the coast of North Carolina. What? Yeah.
Are you fairly limited in what boats will let you go out with a rebreather?
That's a great question. So what's a rebreather friendly dive shop look like? Right? So just because you bought one of these, you can't just take it anywhere in the world, because you need to get 100% oxygen fill. If you fly somewhere, you need to be able to buy the absorbent material that goes in the canister.
Oh, you can't fly with the material.
You don't like that white powder
come
stuff
to
on the airplane.
50-pound keg.
Oh, okay.
You can. That's a 200 canister.
You can, but you've got one check bag with all this stuff, another check bag with your camera. Like
I flown to Bon Air, you know, with these, you know, and I've got my Pelican case just,
Sure.
you know, stacked. There's 2 of those in each
Yeah.
box, you know, but, you know, stacked for the week of diving down there.
That's why the
Okay.
typical kegs that we sell are 44 pounds, so that way you can check them on a typical flight. And yeah, you put an MSDS sheet on the side and it'll make it.
It'll fly.
But it counts as one of your bags. I mean, you have to pay for that,
You're paying for it.
right? So unless you're like a Delta, whatever, platinum.
Tell them, Dave.
It's where you get 3 check bags.
They carry it
in the
down for
world,
me.
right? And you let Dave take your Zorb for you.
Interesting.
Or let him buy your ticket. Is that also works,
Yeah,
right?
yeah,
You
you
buy
know,
the ticket,
my
everybody.
companion. My companion.
Yeah, all the companions get 6 bags as well. So I have friends that are like that. I don't necessarily have that many miles. But sure, so a boat needs to know that you're diving a rebreather, and a lot of places like the aggressor liveaboard boats have a ban. They have no aggressor boat in the world will allow you to dive a rebreather. Even if you show up with an aluminum-88 pure oxygen and your own booster and all the stuff, they still have a rule from the lawyers or whatever that says, you know, rebreather diving is more dangerous, so you can't do it on this vessel. So you need to check beforehand, and then you're going to find that, you know, most geographic areas have 1 or 2 shops that really focus on that, because, you know, buying a booster is $5,000 to $10,000 to fill these oxygen tanks, and, you know, just stocking the sensors that expire every year, or the Zorb that expires every 5 years. You know, it's just expensive to be a rebreather-friendly dive shop. And so you need to concentrate all the rebreather divers to 1 or 2 places until you have the economies of scale that can support it. So in the Florida Keys, there's really only like probably 3 or 4 boosters that I know of in all the Florida Keys. You know, the 20 or so dive shops down there. You know, you go to Roatan, there's only like 2, I think.
Yeah. You go to a place like the Cayman Islands, there's a dive shop on every corner there, you know, and if you're not diving a dive tech, you're hurting for, you know, for support. But again, they buy a container, absorb, and they get the oxygen in liquid dewars, you know, so, you know, that's why people go there, and that's why technical divers, you know, flock to them, because they know the support's there.
Yeah, so that's in general about the training, right? So out of that 6 days, first day you learn how to put it all together. Second day we go to a pool. So you're really only doing 3 days of open water diving out of the 5 or 6 days. And you know, you're only diving for a couple hours a day. So you do an hour-long dive and you come up and you talk about it and you do an hour-long dive. So it seems like a lot. When you break it down, you're only doing 2 or 3 skills per dive. And it's simple, it's relaxed, it's fun. It's not scary. It's not so technical that you have to have an engineering degree to figure it out. You don't have to be super strong to carry all this stuff. You know, you can carry most of it down to the water and, you know, assemble it there and then just put it on and splash in. Or you could complicate it as much as you want, and you could find some personalities of instructors that are very daunting and, you know, very controlling and very aggressive. So just like any other dive shop, I mean, you guys picked one of the most serious but laid back and relaxed, fun atmospheres. Most technical instructors aren't like the culture that you guys have here. They're not as inviting and they're not as encouraging to keep doing that type of diving. They just want to tell you what they know, and you either take it or you don't. And some people, that's great. That's exactly what they need to learn. Other places aren't like that. So you need to shop around for rebreather instructors just like you would a dive community or a dive shop when you go to a new place. Now, if you haven't been diving for a year on open circuit, you'd probably take a refresher, or at least go back to the pool and make sure your gear works. Same thing with a rebreather. So you would maintain it and then go do a refresher. If for some reason you want a gear without diving.
What's wrong with that picture?
Pregnancies or like major surgeries or I don't know, like, you know, you should never voluntarily quit diving, right? So that's a little pitch on training. What I've got here tonight to show you, this is the XCCR. It's made by a company in the Czech Republic called IQ Sub, which just happens to manufacture the Subgravity Defender. So the history of this is that the Hammerhead rebreather that we had 20 years ago was purchased by Subgravity, so the rights to that unit. And this is the evolution of the Hammerhead. It's got a different controller and a different head. But it was manufactured in the same place as this new unit that's less than 10 years old called the XCCR. And they decided that, hey, these two can't compete because they're so similar. So Subgravity negotiated with XCCR, or IQ Sub, to distribute the XCCR for them worldwide, everywhere except Europe, which is where they're based, and they already had a couple of
Can't allow
distributors.
those contracts.
Yeah. So these units look very similar because they're manufactured in the same place. A lot of the same parts interconnect, and you know, the same Save a Dive kit would work for both of these. The Defender has a proprietary controller with different functionality than the XCCR's shear water control. So the buttons are in a different spot, there's more information on the screen. Some people find that it's easier to do certain functions of the dive compared to the shear water. The shear water though, there's hundreds of thousands of these out there and they're more mainstream and more people are familiar with them. The only other difference is that the head of the XCCR, this thing at the top, actually has batteries in it and high pressure sensors, so you know the pressure of what's in these cylinders on the actual handset. Whereas the Defender, you can put transmitters and see them on one of the wireless shear waters that we have now, or you can run analog gauges to see the pressures. And there's no batteries in the head at all. The battery is on this handset. It's actually built into it. So if you were concerned that these lithium batteries could explode and then you could breathe lithium gas, which is impossible because there's so much delrin between the breathing loop and those battery canisters. Well, you wouldn't have that concern here because if this caught on fire, you could just take it off. So there's some sort of philosophical differences between the two, but in general, they work the same way. The same scrubber baskets, the same cell cartridges, or the same sensors, all that's the same.
Are they depth rated?
To 200 meters. So all the connectors and everything is rated to 600 feet. Which. So, yeah, so after this, after we break, you guys can ask any questions. I've got some flyers here for each unit. And then sort of a bonus to the technical diving world, Subgravity also makes something that's convenient now that you have all of this extra weight on you that you're having to push through the water. And this is a underwater scooter or a diver propulsion vehicle that is of the same price range and quality as these units, right? So,
Perfect accessory.
yes. Yeah, so this is like a $7,000 scooter. Just really quick, what makes it a $7,000 scooter is, this is solid delrin, so you could run into the shipwreck or the cave, and it's just going to bounce. The tube itself here is made out of carbon fiber and Kevlar, and then the base of it here is made out of aluminum, so that dissipates the heat from the motor. And then you've got lithium-ion batteries here. This unit's expandable, right? So I can sit up here. This unit is expandable, so you can actually put 2 batteries in it to make it longer. This one's called a reference, right? DPV. You'll see in the flyer here, there's one called a Discovery, and that has 2 of these battery packs in it. And then the switch itself is already set up for that. This one says on-off, but if you buy the other battery and the longer tube, we give you a new sticker that says off, and then battery 1 and battery 2. So that way it's just like side mount. You can run one all the way down, but you've still got a whole other battery there, so they're not ringing together, they're separated in there. This is a servo motor that is watertight, so even if this unit got wet, on the surface when you're checking it, oops, I forgot an O-ring, this whole thing floods, all the connectors, the battery, and the motor is all watertight, so you just rinse it with fresh water, let it dry, figure out why it flooded. The electronics in it are unique. It can go from basically 0% thrust to 100% thrust. So it's not based on the battery, it's actually based on how many rotations per minute or second the motor's going. So that's the uniqueness of the motor. And so if you're diving with somebody with a different brand, you can really dial in exactly where their speed is. Maybe they've only got 5 speed settings, where you've got infinite speed settings, so you can match their speed and move along. If the switches break, this has systems to where you can double click this and it'll go to full speed, or you can pull this lever here and it'll go to 50% speed. So all the switches could break, and then you just move this down and the unit goes to 50% until it runs out of battery. So it's kind of like a get me home setup. So all these safety factors are standard on the unit. We did have the ability to put like a computer on there that through inertia would track where you were at, and essentially like a GPS inside of a cave, but no one bought it. So this is the main product that Subgravity sells, the reference TPV. You'll see some that are a little less, have a different motor and a different power battery. You'll see some that are larger that just has more battery cells in there. But in general, once you buy a rebreather and you start cave diving, very quickly you're going to want this because you get tired of swimming. Because now you have unlimited time to go diving and you just want to look at stuff instead of exercise. So then you just pull the trigger and see if
Is
it's
that
all.
compliant for a check bag?
No. So that's a great question. Can you fly with these? You can fly with everything but the battery. And so in Mexico and Bunny Dive and other places, we've actually shipped these batteries so you can rent them. Several places in the Pacific. So you would take your scooter with you because you know it works, and you would just rent the battery when you get there. So that
How long does the battery last?
So it depends on how fast you're going, but you know, in general, this unit here, which just to kind of walk you guys through how this works, you know, this unit is 42 pounds. At cruise speed, you can go for 4.5 hours, and at max speed, which is 280 feet a minute. So you normally swim at 50 feet a minute, so it's 5 times faster than what you swim. It can go for almost 2 hours.
So you can go to climb on air.
Yeah,
You get around it.
yeah, just circle the whole
Are
island.
they neutrally, what's the buoyancy?
Perfectly neutral. So it's actually, it comes with lead weight. And so if you're transitioning from freshwater to saltwater, you actually adjust the buoyancy, both in the nose as well as the tail. You can see there's weights there. So you get it to where when you let go of it, it just stays right there. Kind of like a rebreather diver. And it's trimmed out too, so you adjust
Just
the
make sure
nose.
it's off.
Full speed.
But yeah, and that's the way you want it, right? So you're not actually pulling yourself through the water, so you're not gripping it the whole time. It's actually got a toe strap on here, so you would hook it to the crotch strap or wherever's comfortable in your rig. So it's actually pulling you via your harness through the water, and then you're just putting your thumb on the trigger, or it's even got a little set screw that you can, you know, lock it in place, or lock it so that you can't open it up. But yeah, so you're just like cruising through and basically steering with 2 fingers.
So what would you say the speed in like miles per hour would be?
Speed in miles per hour would probably
Would you say 50,
be
what'd you do, like speed,
Do what?
feet
Yeah.
per second? You did
85 meters side, and then a big DSLR camera, mirrorless camera strapped to the other side, and then have the scooter here, and you literally can't even, you know, barely reach your tanks, and this thing is pulling you through the water. And if you're doing a drift dive like that in Pompano or Jupiter, you know, you'll actually scooter to the wreck, and then once you're on the wreck, then you can, you know, tie this off and get your camera out, and then take the scooter and clip it off, and then buzz around. If you're going to go inside the wreck, you could leave the scooter and the camera and, you know, all but one of your cylinders, and then get into the engine room. You know, all that stuff requires more training, more experience, more comfort to get you into those environments. But this is the foundation for all that type of diving. You can do it on open circuit, you know, 2 tanks on your back with bell out or with decompression cylinders, but it's very expensive. It's not as healthy. It's not as comfortable. If you're interested in diving in those environments, the quicker you get on a rebreather, the shorter the path is to get to that level of diving. I'm not saying that you shouldn't take an advanced nitrox and a deco or a tech 40, 45, and 50 class in open circuit. Those skills will benefit you on a rebreather, but if you know you're going to go on a rebreather, your whole career gets to the end quicker if the sooner you get on a rebreather. At least that's what I've seen. The prerequisites to dive this unit, anybody in the room, is open water with a nitrox certification. That's all the certifications you really have to start diving a rebreather.
Is there a minimum age? And starting your first one.
18.
18.
Yeah. No. Dave mentioned INTD earlier. They actually offer an open water diver course on a rebreather.
I know.
So you never have to dive open circuit at all. So relatively, that's how simple you can make it. But
There's some agencies that also promote open water classes on a rebreather. However, in the unlikely situation that you need to bail out, what do you bail out to? Open circuit. So you should be an open circuit diver before you go non-open circuit, because you're always going to go back to open circuit.
yeah, and it's just easy and less expensive. I mean, would you like to take your first breath underwater on a $10,000 setup or a $1,000 setup? Right. So it just makes sense.
Do you see these becoming more common and more affordable as we move forward?
So that's an interesting question.
Indoor ocean.
More common, yes. because there's more rebreather friendly dive shops to support them. There's more instructors, there's more manufacturers. Less expensive? Probably not, because of the willingness that you would pay for that. Right? So I'm always going to be willing to pay $10,000 because the economics over a 10-year lifespan is $1,000 a year. I definitely am willing to pay $1,000 a year to have this advantage. So the manufacturers are never going to charge me $5,000 because they know they can get $10,000 out of it. Now there's going to be other units.
Comes along.
Yeah, like Mares has a unit called the Horizon. I don't know exactly what the price is, but it's like half of that.
It's just technology tends to, the computers on these things are much more sophisticated than they were.
They are,
10 years ago.
but Shearwater releases a new, petrol, I think just to up the price. I mean,
They're not gonna make discounts.
it's the way they like counter inflation is they just come out with a new model and charge you more for it.
Yeah, I know.
So I truly don't think that the components will come down, but the mass manufacturing, like you mentioned,
Yeah.
more people get into it, you'll be able to mass manufacture them, and the production cost will go down. But I don't know if the retail price will go down too much.
Do the units have an expected lifespan, like they should last indefinitely, maintained
Yes.
properly, or?
It's just like a car. Let me rephrase. It's like an airplane, right? So like I have an airplane that was manufactured in 1961. I mean, it's in 2022. It's 61 years old, right? That's an old piece of metal to fly in the air at 200 miles an hour. It's terrifying. But I take my 9 and 10-year-old daughter with me all the time because last year I got a checkup and we checked the compression on all the cylinders and lubed every joint and inspected every single beam, and that thing is as good as one that was made last year. So the same thing that happens with rebreathers. If you inspect them and replace parts that are worn, and all the O-rings are changed out every year, I mean, these two units probably have way more than 1,000 hours on them each, and have been ridden hard. I mean, those things have been used in classes and rinsed very well, and we start drinking on the way back in, and the next morning we're like, oh man, this thing's still salty, and you just clean them up and they run again. It's amazing. So yes, they can last a decade or more for sure.
Yeah, if you look at the equipment that we scrap that comes in for service here, it is almost always based on corrosion, which simply comes from not caring. Right? And we've got regulators that, from the 90s that, that's 30 years old that people are breathing on. We still service them and they're still in fine shape. But what kills them is when they get corroded.
So you just have to take care of stuff, for sure. Okay, so to wrap up, we talked about the benefits. Anybody remember any benefit of rebreather diving?
No bubbles.
No bubbles, so it doesn't scare the fish away.
Longer dives.
Longer bottom times.
Less gas costs.
Yep, especially if you're diving deep, right? We know how it works in general. Does anybody have any high-level questions on how the rebreather works? What was that thing in the mouthpiece that makes it go in a circle?
Do they always go clockwise or counterclockwise?
That's a great question. That's why you need to take a class on each unit to figure out which way the mushroom valves go. Right?
Why don't they put the lungs, the one you're breathing out on the back and one you're breathing in on the, so that you get the even.
Yeah, that's also a good question. Really, because it doesn't work like that. This one has 2. It could really just have 1.
Okay.
But that's a great question for sure. If you had to talk to some random person at the shop that said, "Hey, how was that presentation? How much does it cost to get into rebreather diving?" What would you say?
A lot.
You could say that if you're going to have it for 10 years, then it's only like $1,000 a year, right? Which is not that expensive. You guys all dive with regulators that are probably $1,000 a piece. And then, how long would it take you to get certified on the unit? Yeah, a week or so.
Or only 4 days if you certified on Poseidon before you went down to Saltcott.
Exactly. Yep. Okay, so I know that was a pretty brief presentation. I mean, it was long, but it was only a small snippet of what there is to talk about. This is my sales rep website. It's called diveshopservices.com. And if you say /CCR or go to training and rebreathers, there's a whole page here just on the advantages and benefits like we just talked about. The discussion on how it works, why you should get trained, and how a class is structured, so how long it takes, the materials and equipment involved, as well as some information on the actual training agencies to kind of compare the different courses, because that's a whole hour-long conversation about the different religion that you subscribe to, how they equate, and then what the next step would be. And so for you guys, the next step would be to look at your calendar and see if you're available November the 13th or 12th, whatever the Sunday is, because we're going to host at the big pool that you guys use a Rebreather demo day to where you guys could come and...
13th, November 13th, Sunday.
Sunday, November 13th, where you could come, just bring your mask, fins, and suit if you wear one of those in the pool, and then we'll have a unit for you to test drive or test dive there, and you could see what it's like to breathe into those counter lungs. You could see what it's like to go down and not hear any bubbles. You could see what it's like to control your buoyancy by using the wing and the counter lung instead of taking a big breath. And then if you like that, and it plays into your finances and your life and your diving goals, then you could continue on and we could schedule a class on this unit or one of the ones that Dave teaches or Joe Stellini teaches, who's coming next month. I don't really care which unit you buy. I mean, me paying my mortgage does. But my mission in life is to create a dive community that includes the type of equipment and the quality of training that allows you guys to accomplish your dream dive. And so if you have a dive to where you want to take pictures of really unique fish or in a natural environment, or to dive deep, or to dive in a cave and be more conservative to the cave environment, all those benefits, then I think that a rebreather is a good option for that type of dive. Now, whether you like Ford or Chevy, or whether you like Joe or Scott or Dave, my first name's Dave too, so got you there, then that's really personal preference. They all will keep you alive, or they wouldn't be selling them on the market, right? Each unit has its own special pros and cons. Each instructor has a personality that you either like, or you could maybe prefer it was presented a different way. Different places in the world, they dive different units, right, geographically. I said this earlier, if 2 or 3 of you bought one unit, the chances of that 4th unit being bought, because it's here in this environment, is more likely going to be one of those, the same unit that the other 3 people bought, just because you guys all talk about it, and you can share parts, and share the experience, and stuff like that. So I'm happy to answer any questions about what it takes to support a community. You guys have all that stuff here already. And then other places to go diving with it, so how you kind of change what trips you're going on based on is it rebreather friendly, or any specific questions that you have from a technical standpoint or from an agency standpoint or philosophical standpoint about anything technical diving. So with that, I think we've spent enough time talking about all this. I'm going to be here as long as you guys want. You guys have my contact information. That's my email address. You can text me at that cell phone number. And then you saw this website, which is diveshopservices.com, for you to find any more details. Again, I'm just happy to support you guys, whether you ever buy any of this stuff or not. I'm going to be a sales rep hopefully longer than an instructor. So, my goal is to get you guys with the right information and the right attitude and the right support that you need for meeting your dream dive.